Welcome. Yes. Enjoy your stay. Yes, thank you. Burn! How are you, buddy?
Good, thanks, mate. Come down and check this out.
Yeah, I'm really looking forward. First day of opening, looking good.
Yeah, awesome.
Yeah, $120.
Oh, okay. Sure.
Yeah,
here you go.
Thanks. Just trying to make ends meet, and kids with prams, you have to charge more for kids, and it's just
That's
business,
usually not
huh?
how it works, but that's okay. Here you go,
Okay,
buddy.
well, welcome to Waiterassic Park.
What the fuck? Mate, this is shithouse.
What do you mean?
Well, I'm pretty sure these plants, you just went down to the local store and bought a heap of succulents.
Mm-hmm.
They weren't even around then. Is that your dog? You've just shaved your dog, stuck some leaves on it, and painted it green.
How else am I going to represent a Chihuahuadon?
Chihuahuadon wasn't a dinosaur.
Oh. What about all the interactive stuff?
You mean that huge pile of shit on the floor over there?
Yeah.
Mate, putting a large amount of excrement and asking people to feel the warmth coming from it is not really interactive.
Do you know how long that took me to make? I had to have 2 weeks worth of morphine injections and eat nothing but Indian and Mexican food for 3 weeks.
That was you?
Yeah.
Actually, that is quite impressive. Hey, honey, come check this out.
How hard this was to research and try and get the community like I was doing work. I don't know how this is going.
Our next guest is a researcher at the University of Edinburgh. His work involves looking at the evolution, morphology, and genealogy of dinosaurs and their descendants. I fucking love dinosaurs. He is a paleontologist with a blog, several books and TV appearances, as well as over 100 peer-reviewed articles, including publication in Science, Nature Communications, and our favourite, PNAS.
PNAS.
He has recently written another book, and he's here to explain it for those of us that either can't get past the paywall, the scientific jargon, or both. Dr. Steve Brusatte, thanks for joining us today.
Hey, Dr. Steve.
All right. Hey, guys. Good morning from Edinburgh here in Scotland. Thanks for having me.
No worries. We're calling you from lovely Sydney, Australia, which is 6:30
p.m. on a Friday.
On a Friday, which means in about 2 hours I'm going to be drunk.
Yep. Few schooners tonight in your plans, I'm sure.
Yes, schooners. He knows it. He knows it.
A lot of the hipster pubs here in Scotland are starting to serve beer by the schooner. I think because it's smaller, so they can charge more and serve less. But they call it Australian, so it sounds all trendy. I don't know.
No.
Yeah, I think it's a good size. It's not so big that you drink it too quickly, and it's not so small that you get a pint. Yeah, you've got a problem, Wade.
Burn goes and gets those little shandies, a lemonade mixed with beer in a little midi glass.
They're delicious. Okay, and sometimes you get an umbrella in it. All right, let's get into it. So your new book, The Rise and Fall of Dinosaurs, that's available from HarperCollins, Macmillan, Amazon, a bunch of other places for everyone out there, depicts the 150 million year dominance of the most interesting animals, I think, that ever walked the earth. The book, I gotta say, it does a marvellous job of also explaining how paleontologists like you unlock the secrets of the past held in the rock strata. So let's start with some of the science stuff. How much training and research actually goes into recognising the difference between a rock and a fossil?
That's one of the things that we try to teach our students right away, but it's also something that oftentimes we get tripped up on even after many, many years of experience when we're out looking for fossils, because let's face it, fossils are rocks. Fossils are bones and teeth and other bits of ancient animals that have been buried by mud or sand and then turned into rock. So they're part of the rock. They're embedded in the rock, and it means that sometimes it's very hard to differentiate the fossil from the rock, and it's very easy sometimes to mistake a rock for a fossil or vice versa, especially if it's in a place like Scotland here, where we're doing field work out on some of the Scottish islands where it's cold and wet and it's windy and there's lots of bugs around and you're just in a bit of a miserable atmosphere for finding fossils. Your mind can really wander. But that makes it, in a strange, twisted way, it makes it kind of fun because you really do feel like a detective when you're out there looking for fossils. You're looking for these scraps of evidence, for these clues, and each fossil can tell you something new about the age of dinosaurs. And to me, that just makes it exhilarating.
So how do you guys come up with like such a variety of animals from really just like a few bones in many cases?
Yeah, every fossil's different, and sometimes we do get lucky and we find a skeleton or part of a skeleton, several bones connected together. Other times we might just find a few scraps. Sometimes we might just have one tooth or one footprint. It really varies. And so if you have a skeleton or a big part of a skeleton, it's much easier to tell what kind of dinosaur you have. It's much easier to figure out how big it was and what it ate and how it might have stood and moved and all of those sorts of things. If all you have is a single tooth, well, you're going to have to use your imagination a little bit. And, you have to be careful that your imagination doesn't run away from you, because it can be tempting sometimes to take a single bone and start to pontificate about this amazing creature, bigger than a skyscraper. It crushed prey.
It's Godzilla.
Wait a minute. All we have is half a tooth. How can we know that? So we have to be restrained. We have to be careful. But ultimately what we do is whatever we find, we study it very carefully. We measure it. We photograph it. We compare it with all other fossils that we know of. And that helps us figure out what we have. Is it a dinosaur? Is it something else? Is it a new type of dinosaur? If so, what features set it apart? And you just go through that process. And it's a real forensic process when you get down to it.
Oh, geez. One thing I found personally when reading your book, because I'm going to be honest with you, Doctor. Look, I don't know a lot about dinosaurs, but one of the things I really liked when I was reading your book was that you really set the reader up like for a scene. So you'd imagine the typical kind of landscape and what the dinosaurs would be doing and how they'd be behaving and interacting, which I actually found really useful. And it was almost like Jurassic Park-esque, and it was really great. Do you ever like watch those kind of scenes from Jurassic Park or even The Land Before Time and just think to yourself, what the fuck is this shit?
Well, first off, thank you for those kind words, and I'm really glad that you felt that way reading the book, because that's something I wanted to try to do, and my editor was always in my ear telling me this as I was writing, set the scene, talk about the world they lived in, put them into their context. And so that is a little bit tricky in some cases, because these are animals that lived tens or even hundreds of millions of years ago, and we don't know a whole lot about the world they lived in, although we're learning more and more all the time. But it means that we can let our imaginations go wild a little bit and blend what we have from the fossils with a little bit of storytelling. In Jurassic Park and those kind of films, even The Land Before Time, I got to say, I could sit here and I could nitpick. I could go through and say, that dinosaur is too big and that one is the wrong color and the claw on that one isn't quite the right shape and, that one should have a few more teeth. I could do that. That would be a boring interview ever. That would just be terrible. It would drive everybody nuts. I'd sound like some kind of pedantic, elitist scientist, and I'm not going to
see a group of paleontologists at the movies together doing that. They go, that's not right, though, is it? No.
Some are.
Welcome to the skeptic community, Steve. Welcome to the skeptic community. That's what it's all about.
I've been in groups of paleontologists like that go through and in that comic book kind of way, and go through every little inaccuracy. But I don't like doing that, because films like Jurassic Park, they're not science documentaries. They're entertainment. And
I told you, Wade.
Great films. I was 9 years old when the first one came out. I remember seeing it in the cinema. I wasn't really that into dinosaurs at that time. That came a bit later in my life, but I loved that film. It just brought dinosaurs to life in a way that nothing ever had before. And for the most part, those dinosaurs in Jurassic Park, at least the original film, were pretty accurate. They were right in line with the scientific thinking of the day, and really most of the scientific thinking still today. And as those films have gone on, they've veered a little bit more into the world of sci-fi and fantasy, and now you have these dinosaurs, these super dinosaurs, DNA of different species being combined together, and these monstrous Godzilla-sized creatures, and you have dinosaurs being used as weapons and these kind of things. I mean, that is sci-fi stuff. But the dinosaurs, in Jurassic Park, I love them, and that film did great. If you talk to a lot of paleontologists of my generation, people like me that are in our 30s now, you're going to hear a whole lot of us say that Jurassic Park was a big, big, big spark for us to get us into dinosaurs. And even things like, you mentioned The Land Before Time. It's a silly cartoon, but it's a really touching film. I remember watching that constantly when I was young. And just The Land Before Time one.
It's a bit of a tearjerker.
10 or 20 of them, but it was a tearjerker. And those films, what was really great about both of those films is that they made the dinosaurs into characters, and you can really relate to them. And in the book I've written now, of course, it's very different. This is a scientific book. It's an adult, pop science book, and it's scientifically accurate and telling. But I need to keep it grounded in fact. But throughout, I try to make the dinosaurs characters, things that people can relate to, and things that hopefully people can read about and feel the relevance, because these were the animals that dominated the world before humans came onto the scene. And these were the animals that had to deal with real moments of climate change and environmental change and rising temperatures and rising and falling sea levels. So we can learn a lot from these dinosaurs if we can make that connection with them.
So you've done really well to get Wade on board, because I've been trying to convince him for years the interesting parts of geology and things like that.
Wait, this is geology?
I'm a bit more of an eater audience, though. I've always loved dinosaurs. So when you guys sent me this book, I was stoked. I just got a free copy of an amazing dinosaur book that could really speak to me, and I got stuck right in. And then we got sent a second copy, and I gave it to Wade. I'm like, you have to read this. And he rolled his eyes at me. I'm like, no, dude, just trust me. You'll love this one.
We're not pissing in your pocket, Steve. I really enjoyed it. It was great.
Yeah, and so I want to get into some of the details. So you talk earlier about the Permian mass extinction, and that sort of wiped out 90+% of life on Earth about 250 million years ago. But after basically a heartbeat in geological time, it seems like the Earth was teeming with dinosaurs. How can a group of animals so quickly dominate an environment that was essentially intolerant to most life?
It's a really mind-boggling thing to think about. A moment in time when up to 95% of all species die out really quickly. And that's what happened around 250 million years ago at the end of the Permian period. And the reason that happened was because there were these super volcanoes that were erupting in Siberia. And these were not normal volcanoes. This wasn't, Pinatubo or Mount St. Helens or the volcanoes in Italy or Hawaii that we're so familiar with. These were huge canyons, huge fissures in the earth that opened up many, 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 many miles wide, miles long, that just spewed out tsunamis of lava for millions of years. And with that lava came all kinds of noxious, poisonous gases, carbon dioxide, carbon monoxide, sulfur dioxide, all of these terrible things that can pollute the atmosphere and warm up the climate. And it led to a runaway greenhouse. The world got really, really hot really fast, and most species couldn't cope. It was a real hellscape back then. This is the closest life ever came to dying out. But some things did survive. Some things always survive. The Earth is resilient. And a lot of the top species, the top of the food chain animals, during the Permian, they died out. But the things that survived were smaller, more adaptable animals, and among those were some small reptiles. And they helped to repopulate the world afterward as the Earth started to heal when those volcanoes stopped erupting. And so some of those small reptiles were these really weird-looking, gangly, cat-sized creatures. They walked around on four legs. They had these really skinny, stilty legs. They only weighed a couple of pounds at the most, and they were very rare animals. They were living in the shadows. But these things were the immediate ancestors of dinosaurs, and they turn up right after that extinction. And at the same time they turn up, we start to see the first turtles and the first lizards and the first crocodiles and even the first mammals. So many of the most familiar animals today were all getting their start right alongside each other after that extinction. And those animals were all vying with each other to become supreme. And so it took many tens of millions of years for dinosaurs to really rise up to eclipse, especially their crocodile cousins, and spread around the world and become truly dominant. But it was that original extinction that paved the way for dinosaurs.
I was going to say that when people like envisage a dinosaur, like they probably picture like a T-Rex or a Stegosaurus or some sort of massive sauropod. But they didn't really look like that, did they, when they first started out?
That's absolutely right. When we think of dinosaurs,
Well done, Wade.
it's a great question, and it's a striking question, really, and it's a striking thing to think about, because when you say the word dinosaur, I think the image that comes to mind is T-Rex. T-Rex chasing down the Jeep in Jurassic Park, or a Brontosaurus, the huge skeleton, the size of an airplane, in a museum, standing underneath it, just in awe of the size and the strength of that animal. But that's not how dinosaurs started. Dinosaurs were an empire. They were around for over 150 million years, but like any empire, it took them a while to get going. And the very first dinosaurs were these small, cat-sized, very humble, almost forgettable animals that were living in the shadows, but they were adaptable. They were evolving quickly. They were really good at living in anonymity. And when they had their chance, as the world was being reshaped after this extinction, they took their chance.
Wow.
So how were the dinosaurs like the sauropods able to get so massive?
This is a question that goes all the way back to when some of the first dinosaur bones were found and studied by scientists in the 1800s. And in fact, when the first bones of these big long-necked sauropod dinosaurs, these Brontosaurus-type dinosaurs, when the first bones of these animals started turning up, the scientists of the day had no idea what in the hell these things could be. These bones were massive. They had never seen anything of that size. The only thing they could fathom was that they were the bones of some sort of enormous primeval whale, because whales are the only thing today that are anywhere near the size of these dinosaurs. But as more fossils came to light and more skeletons were found, it was determined that no, these things aren't whales. They're found in rocks that were laid down on the land, and they don't look like whales at all. They have these 4 columnar limbs, and they have these huge bellies, and they have these long necks and these tiny heads. This is some sort of enormous reptile. But how did they possibly become so big? And a lot of the early explanations said things like, well, maybe the Earth was different back then. Maybe gravity was weaker, so things could get bigger. Maybe there was more oxygen in the atmosphere, so things could get bigger. But now we know that's not the case, and it was the animals themselves that held the key. These animals were really special, and they had a whole set of superpowers that allowed them to become big. The long necks, for example, those necks allowed these dinosaurs to reach up high into the trees and eat food that no other dinosaurs could. They had their own buffet, essentially, of choice leaves that they could eat and eat and eat and eat. And their skeletons were lightweight. They were huge animals, but their bones were largely hollowed out by what are called air sacs, these extensions of the lungs, these balloons that came out of the lungs. So that meant that you could become really huge, but not so bulky that you couldn't move around. And those are just 2 examples, but there's many other features of their skeletons that when you combine it all together, when you kind of put that Lego set together, that allowed these things to become so huge. And that's why animals today aren't so big. No mammals are that big. Nothing quite has those same long necks. Mammals don't have air sacs that can hollow out bones, and so on.
Is that similar to what we see in birds today?
It is. It's very similar. And the more we learn about dinosaurs, the more we see just how bird-like they were. And that makes total sense, because birds evolved from dinosaurs. Birds are dinosaurs, and that's a story we can maybe get to in a moment. But so many features of dinosaurs, we see those same things in birds. A lot of dinosaurs had wishbones, for instance. And a lot of dinosaurs had feathers. We now know that so many dinosaurs, maybe even all dinosaurs, had some type of feather. And that's not a guess. That's not something that artists are just doing when they're drawing pictures of dinosaurs. It's not a made-up story. This is for real, and we know it because we have thousands of fossils, real dinosaur skeletons, mostly from China, immaculately preserved, covered in coats of feathers. And that is the slam dunk evidence that tells us that birds evolved from dinosaurs.
And these feathers, did they serve the same purpose as in birds today, or were they used differently?
This is one of the most fascinating news stories in paleontology over the last decade or so. We're learning so much more about feathers, and particularly the evolution of feathers. In today's world, birds are the only thing that have feathers, and they are unique signature characteristics of birds. If you find a feather, you know it came from a bird. And if you see a bird, you know it's going to be covered in feathers. But we now know that a lot of dinosaurs had feathers, and we now know that feathers in the past were quite different from today. I think we think of feathers as what birds use to fly. And of course they do. The feathers make up the wings of birds. But birds also use feathers for many different things. They use feathers to keep warm. They use feathers to display, so to look attractive to mates or intimidating to rivals. They use feathers to cover up their eggs in the nest to keep their eggs safe. They use feathers sometimes even to swim. So there's lots of things feathers do. And when we look at these fossil dinosaurs with feathers, we can trace the evolution of feathers across the family tree of dinosaurs, and we can see that the very first dinosaurs with feathers had really simple feathers. They were just little strands that looked like hair, basically. They were just little tufts. And they coated the bodies of these dinosaurs, and they probably evolved to keep these dinosaurs warm, the same reason we have hair. But then there was one group of dinosaurs that started to modify those feathers. The feathers got longer. They started to branch out. Each one started to branch into multiple bits, and they got a bit flatter. And then they started to line up on the arms, and that turned into wings. And meanwhile, those same dinosaurs were getting smaller and smaller and smaller. And it's that group of dinosaurs.
So they were kind of like the hipster dinosaurs then, weren't they?
They were, and their feathers...
Ordering schooners.
Yeah,
Yep, they would have, and a schooner would have been the right size for these tiny dinosaurs. You wouldn't schooner, you'd need a keg. But these were some of the meat-eating dinosaurs, the Velociraptor type dinosaurs. These were the things that evolved into birds. They were smart, fast, energetic, dynamic dinosaurs, and they got smaller and smaller. Their arms got longer and longer. Their feathers were modified into wings, and it got to a point in evolution where they started flapping around, and they developed the ability to fly, and that's where birds came from.
I noticed in your book that you speak about like T-Rexes and to try and envisage them as like even just baby T-Rexes, like obviously hatchlings, although we've never come across a T-Rex egg. One of the things that you mentioned is that they'll be really, really tiny. How are they protected? Were they protected, or were they much like you're on your own as soon as they hatched?
We're learning a lot more about that too, and we now know that some dinosaurs were really good parents. We also know that some dinosaurs were not very good parents. There was a whole spectrum of behaviors. Some dinosaurs had nesting grounds. We can find the eggs and the nests of dinosaurs, and sometimes there's lots of them together, layer after layer, and that tells us that there was a nesting ground there that existed for many, many, many generations. It seems like, by and large, the really big, long-necked dinosaurs were not particularly good parents. They just kind of laid their eggs and dumped their eggs somewhere, and they laid a bunch of them, and it was a survival of the fittest thing. They would just let their little babies go.
Deadbeatosaurus.
Yes. some real Child Protective Services kind of issues there. They were problem parents, let's say. But on the other end of the spectrum, you had a lot of the meat-eating dinosaurs, what we call the theropod dinosaurs, so the T-Rexes and the Velociraptors and the sorts of dinosaurs that evolved into birds. And they seem to have been really good parents. And there are even some fossils of parent dinosaurs sitting on top of their nests of eggs with their arms outstretched, covering the eggs, keeping them warm, just like modern birds.
Oh, I got goosebumps. Seriously, I got goosebumps. That's so cute.
This T-Rex.
But the T-Rex's arms, I don't think it'll do much of a good job.
T-Rex itself, oh my goodness, yeah. T-Rex trying to sit on its nest of eggs. I think that would have been even worse than letting your little babies out into the wild with no protection. It was much easier for the smaller ones to, physically take care of their nests.
Wow. So we do see this sort of behavior that's very bird-like, some characteristics that are bird-like, and whenever I picture like a feathered dinosaur, I immediately think of Archaeopteryx. But then when you think about things like Triceratops, do you think calling Triceratops and Archaeopteryx and everything all of these groups, dinosaurs, perhaps remove some of the appreciation people could have for the diversity that existed in the fauna at this time?
I don't think so. I think we just have to be true to evolution, and all of these animals, they're all part of the same group. And we should think about dinosaurs how we think about mammals today. And mammals have huge diversity. Think of all the different types of mammals, everything from primates that swing through the trees, to rats and mice that scurry around, to moles that burrow, to bats that fly, to whales that swim. And dinosaurs were like that too. Dinosaurs had an incredible variety of shapes and sizes and diets and behaviors, and they lived all over the world, and they lived for well over 150 million years. And birds are part of that diversity. And it is a little bit weird, I think, for a lot of people to think of birds as dinosaurs. There's something there that just doesn't quite jive for a lot of people, especially people, I think, of, slightly older generation. I'd even put myself in this, that grew up reading these books that talked about dinosaurs as these epic failures, these, drab-colored, dim-witted animals just hanging around waiting to go extinct. That doesn't jive with this newer idea that birds are dinosaurs. But we should think of birds the same way we think of bats. Bats are a strange type of mammal that evolved the ability to fly, and birds are a strange type of dinosaur that evolved the ability to fly. And that ability to have a wing and flap around in the air, that is what saved these birds when this asteroid came down 66 million years ago and wiped out all the other dinosaurs.
So cool.
Okay, yeah, that is cool. How did dinosaurs dodge the earlier two extinctions then during the Triassic and the other one at the end of the Jurassic?
That's a great question, and I don't have a good answer there. This is one of the great unsolved mysteries about dinosaurs, and I think it's something that the next generation of paleontologists will have to figure out. And that's really a big mystery when it comes to the end of the Triassic. This was about 200 million years ago, and this was when you had the supercontinent of Pangaea. You had all the land together into one huge megacontinent that stretched from pole to pole. And this is the world that the first dinosaurs grew up on, along with the first crocs and turtles and mammals and all these animals that were vying for supremacy after that and Permian extinction. But then about 200 million years ago, Pangaea started to crack. It started to break up. That supercontinent started to fracture apart, and the little bits of land started to move away from each other. And ultimately, that's led to the continents where they are today. But as that happens, you just didn't have land that was moving apart. You had lava that came up to fill the gaps between these puzzle pieces that were now moving away. And so this was another time of supervolcanoes. And this was another time of toxic environmental poisoning, of runaway global warming. And a lot of things died, especially a lot of the early crocodiles died. There was this great diversity of crocodile-type animals that were living with the first dinosaurs. There were crocs that were top predators, the size of buses. There were crocs that ate plants. There were crocs that were covered in armor.
Shit.
There were crocs that were sprinters that looked like greyhounds.
That's amazing and terrifying.
Imagine a croc the size of a bus. I mean, that's up there with T-Rex as far as just blood-pulling nightmare stuff. And they were the top animals throughout much of the Triassic period. The dinosaurs were playing second fiddle to them. But for whatever reason, those crocs couldn't handle those volcanic eruptions when the supercontinent started to split up. Whereas dinosaurs, they seemed to just sail right through. They kept on trucking. They just went right through into the Jurassic period. And we don't know why. What was it that made the crocs so susceptible? What was it that made the dinosaurs so resilient? And I'd love to know the answer to that question, because we want to know when climates and environments change really suddenly, what lives and what dies. That's really relevant to our world today.
Yeah,
So
absolutely.
if you're looking at specimens, then what's the big difference between a crocodile and a dinosaur, or a crocodilian and a dinosaur?
It can be really difficult. I mean, nowadays it's pretty easy. Crocodiles today all look pretty much the same. They're all these animals that live kind of, where the water meets the land, these semi-aquatic, sprawling, green-colored, scaly animals. But back in the time of dinosaurs, especially in the Triassic period, there was such a diversity of crocs, and a lot of them really looked like dinosaurs. Or maybe put another way, a lot of the earliest dinosaurs really looked like crocs. And for a long time, scientists were mistaking the bones and the fossils of these groups for each other. Somebody would find a fossil of one of these early crocs and think it was a dinosaur, or vice versa. We've now figured out, for the most part, good ways to tell them apart. It comes down to the nuances of their bones, the sort of ways that, medical doctors can tell apart different diseases from the symptoms, really, really careful, meticulous forensic work. But it can be tricky. And I think what that means really is that the Triassic period was this great time of evolutionary experimentation. You had all these crocs and all these dinosaurs and the turtles and the mammals and the lizards, all of these things evolving together during this time of recovery from that first big mass extinction, but also a time when the world was just becoming much more diverse. And so this was an arena, this was a battlefield, and evolution was doing all sorts of interesting things.
Wow. And going back to the previous link that you've made between dinosaurs and how really birds are the closest things we have to dinosaurs today, is it possible that dinosaurs would have chirped or sang like birds at any point?
That is a really fascinating question to think about what dinosaurs would have sounded like. We have a pretty good idea what a lot of dinosaurs looked like. There's even ways now we can tell what color they were, which is just incredible.
That's awesome.
So
But as
rad.
far as what they sounded like, we don't know a whole lot. In a lot of films, they're portrayed like mammals, really. They roar like lions, that sort of thing. That's probably not what they would have sounded like. They probably didn't have that type of vocal cord system that mammals have. We do know in a few cases, some of the very oldest fossil birds, that they had voice boxes like modern birds. So that means it's highly likely that at least some dinosaurs, some of these meat-eating dinosaurs, probably would have chirped and sang like birds of today. Now, some of the other dinosaurs that were much more distant relatives probably sounded different. And some of the duck-billed dinosaurs, for instance, these big plant eaters that had these bills, these beaks at the front of their mouths that they would use to snare plants off the tree, leaves off the trees. A lot of them had these big convoluted crests of bone above their head, and these crests were connected to the nasal passages. And those things have been modeled by engineers, the sorts of engineers that make musical instruments. And they've shown using computer software that those sorts of crests would have made really low-pitched bellows. So some dinosaurs, I think, would have had these low-pitched bellows that probably would have echoed across the landscape. Other dinosaurs probably would have chirped a lot like birds, and you would have had a great diversity of dinosaur songs back during the Mesozoic era.
So are you saying before that we now know what color dinosaurs were? I got to know, what color are dinosaurs?
We do know in some cases, and this is something I talk about. I tell the story in the new book, and it's one of my favorite stories because when I was growing up, again, not too long ago, in the late 80s and throughout the 90s, almost every book about dinosaurs said something along the lines of, we'll never know what color they were. So let your imagination run wild. They might have been green. They might have been brown. They might have been purple. They might have been polka dotted, but we'll never know. But we now do know. And that is just a testament to how we should never say never in science. We should never say something is impossible because that closes our mind. And the way that we know is because a grad student, a guy named Jakob Winter, about a decade ago, he started to look at fossils under really high-powered microscopes, particularly feathers. And he noticed that there were these small little vessels, tiny little things. They looked like cells. And these things are called melanosomes, and they bear pigment. They contain pigment. And melanosomes of different shapes and sizes carry different types of pigment. So by finding these melanosomes, by locating them under the really high-powered microscopes, we can see that, okay, this dinosaur has brown melanosomes. This one has white. This one has black. And that's just incredible that this.
That's so cool.
And we know that dinosaurs now had all kinds of flamboyant colors. They were not all these boring earth tone greens, grays, browns that they used to be portrayed. Some dinosaurs were white. Some dinosaurs were black. Some dinosaurs had shiny iridescent feathers like crows. Some dinosaurs were ginger. Some dinosaurs even had ringed tails like raccoons. So they had such a diversity of colorings, and they probably would have been a lot like birds today. Just think of all the fantastic colors that birds have.
That's amazing. That's so.
Yeah.
I'd love to go back into my colouring books when I was a kid, the dino colouring books, and have another chance at them now.
Well, you'd know the ones that were like go out there by themselves and stuff like that. It'd be the ginger ones.
I'm not going to make any ginger jokes.
Yeah, I'm leaving that alone as well.
Army of people chasing me down here, but yeah, they dinosaurs to laugh at, unfortunately. But a lot of them would have been pretty vicious killers, despite being gingers. Tell a ginger joke to them, or else you might have been gutted by one of their.
Especially in Scotland, you'd be in a lot of trouble. There'd be a fair few gingers around where you're working.
That's true. So, did dinosaurs really go extinct at the end of the Cretaceous period? What happened to them?
They did, except for birds, of course. And so a few birds did make it through. But otherwise, all the other types of dinosaurs died out. So the T-Rex types and the Brontosaurus types and the Triceratops types and the duck-billed types, the armored types, the dome-headed types, all of these classic iconic dinosaurs, they all died. And they all disappeared really suddenly 66 million years ago. And they disappeared all around the world at the same time. And this is the exact same time that an asteroid hit the Earth. And this was not any normal asteroid. This was a 6-mile wide rock, the size basically of Mount Everest. And it was traveling faster than a jetliner. And it smashed into the Earth with the force of over 1 billion Hiroshima bombs. And it punched a crater in the crust that was over 100 miles wide. And as it did so, it unleashed a cascade of destruction. Volcanoes, earthquakes, tsunamis, wildfires, hurricane force winds. These things reshaped the Earth within a matter of minutes, days, and weeks. And the dinosaurs couldn't cope. In fact, most things couldn't cope. Some 70% of living things died. And a few birds made it through. And a few mammals made it through. Not many mammals. A lot of mammals died, but a few mammals made it through. And among those mammals were our ancestors. And it's a really kind of cosmic story when you think about how all this stuff is connected. It was the death of dinosaurs that paved the way for us. And it was because we had these ancestors that were small, that were adaptable, that were resilient, that could hide easily, that could eat a lot of different types of food. They had what it took to survive that global meltdown. Whereas dinosaurs, they had been around for 150 million years. They were at the pinnacle of nature. They were living everywhere, every continent, all over the world, every conceivable environment on land. There would have been billions of dinosaurs that woke up that morning. And they would have been, if they could have thought it through, they surely would have been confident of their place at the peak of nature. But then so quickly that came crashing down. And as I tell this story in the book, I raise this question, and it's a question I'd like people to think about. If it could happen to the dinosaurs, could it happen to us? We now wear that crown that the dinosaurs once wore.
For a lot longer, too.
Yeah, for a lot longer. Humans have only been around for about 200,000 years, at least Homo sapiens. Dinosaurs were around for 150 million years and longer. So we are just a little speck of dust when it comes to the history of life. And I think we have to remember that our planet is very old. And our planet is fragile, and we're just part of one long evolutionary story. And there have been many other groups of animals that have had their own empires before us, and they've risen and they've fallen for different reasons. And the dinosaurs, they were the ones that were on top before we were, and they were really good. They were really successful. They were hugely dominant animals. But then when this sudden moment of climate and environmental change happened, that couldn't save them. They were dominant one day and they fell the next. And that's not to scare people to say, hey, human civilization is going to collapse tomorrow. No, we're different than the dinosaurs. We have a choice. We have much higher intelligence. We have an ability to change our planet. And hopefully that means an ability to preserve things and an ability to make ourselves resilient to changes in climate and environment.
You'd think that, wouldn't you?
You'd hope so.
You'd think that.
It is a thought that's both fascinating and terrifying in equal parts, isn't it? All right, Steve, last question for you. What is your favorite dinosaur?
Oh, I knew you were going to ask it. I knew it.
Fuck it, I knew it too. He's shit. He's such a shit interviewer.
I have to know. A guy that knows a lot about dinosaurs. You got to know what the best one is, right?
Yeah, it'd be embarrassing if you didn't ask it. Kids ask me this a lot when I go into classrooms. And what I'll usually tell the kids, I'll wind them up a little bit, and I'll ask, okay, how many of you have siblings? And some will raise their hand, and I'll say, does anybody ever ask your parents, which one of you is their favorite?
It was always my brother.
Well, I feel that way with dinosaurs. You can ask me which one is my favorite. I know the answer, but I have to be nice, and I can't really tell you. And the kids, they laugh a little bit, but then I say, okay, look, in reality, dinosaurs were so fascinating. I've been so fortunate to study lots of different kinds of dinosaurs around the world and to name something like 15 new species of dinosaurs now. And I get so enthused about whatever dinosaur I'm working on at the time. If we have a new species in front of us that I'm describing, that one has my attention. That one has my enthusiasm. I can't wait to get that dinosaur out there, to announce this discovery to the world, this totally new species we never knew about. But by and large, though, those new species come and go. But through it all, the one that keeps a hold on my heart is T-Rex. It's got to be T-Rex. I know it's a big cliche to say that. Everybody says T-Rex. But my goodness, you go to a museum, you stand under the skeleton of a T-Rex. This is an animal that is unlike anything that's alive today. This was the biggest pure meat eater that has ever lived on land in the history of Earth. It was the size of a bus. 13 meters long, 7 or 8 tons. It had a head that was as long as an average human is tall. It had 50-some teeth in its mouth, each one the size and shape of a banana, and they were able to crunch through the bones of their prey. And then you had those pathetic little arms that were just kind of dangling there. So this is an astounding animal. And how can you not be moved?
Shame it couldn't even flip you off, though.
Two-finger. It only had 2 fingers, but the 2-finger salute.
How'd it make the bed?
Crushed through you with its skull.
Well, look, it's times like this when I think to myself with Bern and I that we're so fucking lucky to speak to so many interesting people, and that's one of those moments. And we can't thank you enough for coming on the show. The Rise and Fall of the Dinosaurs will be available, I know, very soon in Australia. I know it's available in North America, I believe, at the moment.
That's right. It's
Correct,
just come out this week, just a couple days ago. So I'm in this kind of nervous and excited phase of, endlessly and obsessively checking Amazon, seeing what readers are saying, seeing what the reviews are looking like. And I'm just, looking forward to seeing what people think of it, because I think it's a cool story, the story of dinosaurs, where they came from and how they rose up and how they died out. And, I hope that people take a liking to it.
Well, I can tell you from a person who wasn't in dinosaurs too much before, you've got me hooked, and it's fucking
right. That's
great
what
book,
I
mate.
love
Well
to
done.
hear, and I'm really glad that you guys like it. And thanks for the chance to come on and talk with you guys. But I guess it's getting close to 7:30 p.m. on a Friday for you guys, so you know where you guys need to get going to.
Schooners.
That's right. Wade's mouth is watering right now. Steve, thank you very much for joining us.
All right, Vern, Wade, thanks a lot, guys.
Thanks, mate.
Bye.